Welcome to another video by Adeptis Academy. Electricity powers our modern world. From the lights in our homes to the devices in our pockets, we rely on a constant flow of electrical energy. But this powerful force needs careful control. Without it, electrical currents can surge dangerously, damaging our electronics and even posing fire hazards. This is where fuses step in as crucial safety components. Fuses are small, yet mighty protectors within our electrical circuits. They act as sacrificial elements, designed to interrupt the flow of electricity when a fault occurs. Imagine them as vigilant guards, always monitoring the current passing through. When the current surges beyond a safe level, the fuse acts swiftly. It breaks the circuit, stopping the flow of electricity and preventing damage to valuable devices. Think of it like a safety valve on a pressure cooker, releasing excess pressure to prevent a catastrophic event. Fuses provide peace of mind. They are essential components in our homes, cars, and countless electronic devices, ensuring that our interaction with electricity remains safe and controlled. To understand the elegance of a fuse's protection, we need to delve into its inner workings. Despite their simple appearance, fuses are cleverly designed devices. At the heart of every fuse lies a thin wire or metal strip meticulously calibrated to carry a specific maximum current. This wire, often made of materials like copper, aluminum, or specialized alloys, is the key to the fuse's operation. When an electrical current passes through the fuse, this wire heats up. The higher the current, the greater the heat generated within the wire. A fuse operates on a simple yet effective principle: heat and its effect on metal. When an excessive current flows through the circuit, the fuse wire heats up rapidly. This rapid heating causes the wire to reach its melting point. The metal melts and breaks the circuit, interrupting the flow of electricity. This intentional burning out of the fuse wire is the crucial safety mechanism. It prevents the excess current from reaching sensitive electronic components or appliances, safeguarding them from potential damage or even fire hazards. Just as electrical systems vary widely, so do the fuses designed to protect them. Fuses are not a one-size-fits-all solution. They come in a variety of types, each tailored to specific applications and current requirements. One of the most recognizable types is the glass tube fuse. Often found in older homes and vehicles, these fuses feature a thin wire visible within a glass cylinder. The glass provides a visual indication of a blown fuse, as the melted wire is clearly visible. Ceramic fuses offer a higher level of protection, capable of handling larger currents. Encased in a robust ceramic body, these fuses are commonly used in industrial settings and high-power applications. Blade fuses, with their distinctive plastic bodies and metal blades, are prevalent in modern automotive electrical systems. Their compact design and ease of replacement make them a practical choice for vehicles. For applications requiring reusability, resettable fuses, also known as circuit breakers, offer a convenient alternative. These devices automatically interrupt the circuit when an overload occurs and can be reset once the fault is cleared. Selecting the correct fuse for a specific circuit is paramount for ensuring both safety and functionality. Using the wrong fuse can have serious consequences, potentially leading to damage or even fire hazards. The key parameters to consider when choosing a fuse are its current rating and voltage rating. The current rating, often expressed in amperes, indicates the maximum current the fuse can handle before it blows. Equally important is the voltage rating, typically measured in volts. This rating signifies the maximum voltage the fuse can safely interrupt without the risk of electrical arcing. Choosing a fuse with a current rating lower than the circuit's requirement can lead to nuisance blowing. The fuse might blow frequently, even under normal operating conditions, causing inconvenience and potential frustration. Conversely, using a fuse with a higher current rating than necessary poses a significant safety risk. In the event of a fault, the oversized fuse might not blow as intended, allowing excessive current to flow through the circuit and potentially causing damage or fire. Determining the appropriate current rating for your fuse requires a basic understanding of your circuit's power consumption. The current rating should be slightly higher than the normal operating current of the circuit, but low enough to interrupt the flow in case of a fault. For simple circuits, you can often find the required current rating listed on the device or in its user manual. However, for more complex systems, consulting an electrician or qualified professional is always recommended. The voltage rating of the fuse is equally important, though often overlooked. It's crucial to choose a fuse with a voltage rating equal to or higher than the circuit voltage. Using a fuse with a lower voltage rating than the circuit voltage can be dangerous. When a fault occurs in a circuit with an underrated fuse, the fuse might not be able to interrupt the arc effectively. This can lead to a continuous flow of current, even after the fuse has blown, potentially causing a fire hazard. Remember, selecting the right fuse is not a guessing game. It's about understanding the principles of electricity and making informed decisions to protect your devices and ensure safety. The consequences of using an incorrect fuse can range from minor inconveniences to significant safety hazards. Understanding these risks underscores the importance of proper fuse selection. Perhaps the most common issue with using the wrong fuse is nuisance blowing. When a fuse with a current rating lower than the circuit's requirement is used, it can blow frequently even during normal operation. While this might seem like a mere inconvenience, it can disrupt the functionality of essential devices and lead to frustration. Imagine your refrigerator repeatedly losing power because of a fuse that's too small for its needs. Far more concerning is the risk of fire caused by using an oversized fuse. When a fuse with a higher current rating than necessary is installed, it might not blow, even when the circuit experiences a dangerous surge. This failure to interrupt the flow of excessive current can lead to overheating of wires and components within the circuit. In extreme cases, this overheating can ignite flammable materials nearby, potentially resulting in a fire. The risks associated with incorrect fuse selection highlight the importance of treating these small safety devices with respect. Never substitute a fuse with a higher current rating than recommended, and if you're unsure about the correct fuse to use, consult a qualified electrician. As technology advances, so do the methods we use to protect our electrical systems. Fuse technology is no exception, with ongoing research and development leading to innovations that improve safety, efficiency, and reliability. One area of advancement is the development of resettable fuses with enhanced features. These sophisticated devices offer more precise current sensing and faster tripping times, providing enhanced protection for sensitive electronic components. Another area of innovation is the integration of fuses with smart technology. Smart fuses can communicate wirelessly, providing real-time data on circuit status and alerting users to potential issues before they escalate. Nanotechnology is also playing a role in the evolution of fuses. Researchers are exploring the use of nanomaterials to create fuses with improved performance characteristics, such as faster response times and greater accuracy. These advancements in fuse technology demonstrate the ongoing commitment to enhancing electrical safety and reliability. As our reliance on electronic devices continues to grow, so too will the importance of innovative fuse technologies in safeguarding our interconnected world. In a world increasingly reliant on electricity, understanding the role of fuses is not just a matter of technical knowledge, but an essential aspect of safety consciousness. Just as we learn basic first aid or fire safety, grasping the fundamentals of fuses empowers us to interact with electricity safely and responsibly. Knowing how to identify a blown fuse, select the correct replacement, and understand the risks of improper fuse usage can prevent damage to valuable electronics and, more importantly, safeguard lives. It's about shifting from passive users of electricity to informed individuals capable of identifying and mitigating potential hazards. This knowledge is particularly crucial in households with children, who may be naturally curious about electrical appliances and outlets. Educating them about the importance of fuses and the dangers of tampering with electrical systems can prevent accidents and foster a culture of safety. Ultimately, understanding fuses is about taking control of our electrical environment. It's about moving beyond simply plugging in and switching on, and instead engaging with the invisible forces that power our modern lives in a safe and informed manner. By embracing fuse knowledge, we empower ourselves to harness the benefits of electricity while mitigating its potential risks. Thank you for watching the video, and see you soon.